presentation mode.
Sir?
Yes.
One question for you, sir.
Excellent. I think my preaching helped a little bit there. Go ahead.
Sir, if we want to design a compiler or OS, then what the requirements we should take, sir? What are the requirements we should take?
That's a good question. So the question is, if you want to design a compiler or an operating system, what are the requirements that you should take? Who gives you the requirements, right?
Yes,
Requirements from whom, right? Requirements from whom, right? So most of the time, the compilers and all that are produced by the companies, right? What is a compiler? You learned in your computer organization class, right? As one faculty member put here, all of you took a class on computer organization and compiler design, right? Either second year, third year, or first year. I don't know when you took it, right? What does a compiler do? It takes a program, a programming language, right? The input to a compiler is a program written in a certain programming language, right? Let us say I say I'm designing a C++ compiler. So what is the input to that? What is the requirement? The input to that should be a C++ program, correct? So when you're writing a compiler, you are basically, compiler is nothing but what we call it is a language processing program. So the input would be what language that is. And the output should be what? When you're writing a C++ compiler, your faculty member would have told you in your class the following thing. Let us say, like for example, 25, 30 years ago, I was an engineer in Hewlett Packard. We had a C++ compiler for the HP's PA RISC architecture. Okay. So HP had its own hardware, right? And it was based on an architecture called precision architecture, RISC, reduced instruction set computing. So when you talk about architecture, your faculty member would have told you that, hey, there's something called a specific machine code. I mean, it's not really complete machine code. It is at the assembly language level, right? There's an instruction set that particular machines understand, right? You have learned those concepts, what those instruction sets are. Like registers, every computer machine would have a bunch of registers at the lowest level, right? So when the C++ compiler was written for HP architecture, it was taking a C++ program and converting that into the language understood by the HP's architecture. Okay. So that is the output. So you need to understand the architecture language of the machine, and you need to understand what is the input language for which you're writing the compiler. Now we have moved away from that, right? Now we write what is known as object code. When Java came along, why did Java become popular when it first came? Because what the Java, when Sun Microsystems produced that, what they said was, you write a program once and you can execute it on any machine architecture. Whether you take that program and execute it on a Unix machine or a Windows machine or Mac machine, the program should run, right? Because they instead of converting that into a machine architecture code, what they did was they defined a new code called object code. The object code is machine independent. And then there are interpreters which then translate that object code into the respective machines. Okay. I'm assuming you learned all that in your class. So I hope I answered your question. I just had to give some additional information there. Any other questions?
So we are writing compiler compiler in C programming and C or C++ programming if we writing, then how can the system could understand C and C++? The compiler code also should be translated into machine code, no sir?
Yeah, at some point it should be translated. Like for example, the C compiler, when first C language came, the C compiler was written in C language itself. Okay. The program itself was written to compile the same programming language. You can write that. You need some language to do that, right? And then the programmer then builds what are known as these tree structures, right? You build a lexical tree and a semantic tree and all that. Then you say, okay, if I see this one, convert that into the following construct, which is machine language or the object code. It's a recursive thing, right? It's a recursive programming. When you see when you look at the C programming language compiler, the compiler itself is written in C language. By the way, the base code for all the Java compilers, whether you know it or not, is C programming. So when Java first came and we were writing the Java compiler, the compiler itself was written in C language to interpret the Java construct. So that is the principle of recursion. So nothing wrong with that. Okay. Any questions? So you're writing a compiler
Thank you, sir.
now in the 4th year?
Yes, sir. We are 4th year, sir.
Okay. Okay, got it. Okay, good. That's excellent. Any questions from JNTUB? Okay, let's move on here. I'll move through this fast because we covered a lot of this in the previous slide deck too. Okay. So ultimately, when you're coming to design and implementation phase, the output of this phase would be executable software. Okay, everyone understands that. Now notice software design is a creative activity. Okay, there is no magic to identifying the architectural components and all that. In today's world, it has become a little bit more easy because most of the time you are working in teams. Okay. Now, one of the big decisions that we make in the industry is, do we build it or do we buy it? Okay. Now, when you buy, they are called the off-the-shelf system, right? The COTS architecture. That means you are buying bits and pieces of it. Okay. And then you're customizing to user requirements. Okay. Example given here is medical record system, right? If you already have packages available, buy them and customize them. Okay. Now, the opposite of that is developing it on your own. So there are always trade-offs. I can give you my own personal example. When we built our Lensu platform, what we did, we spent about 8 months studying the technology which is out there, which is already there that we could reuse. So we analyzed Moodle, we analyzed Drupal, we analyzed Sakai. These are all the various learning management system oriented platforms that are already there. And most of them are open source software, right? So we used a combination of open source software and custom development to build our platform. Okay. Now, whenever we are using something which is out there, we need to be careful about how to customize it. Because when you have open source software, there's not much documentation related to that, right? So oftentimes we stumble. So we have to figure things out by going into the code. So you have some challenges like that. Another example that I can give you is after we build our software, Cisco took a demo of our product because they wanted to build a next generation collaborative learning platform. So they invited us, they took demos from us, and then they decided instead of buying us, they'll build their own for whatever reason, right? But the choice is based on your business objectives And the choice is also based on, this is where the practical insight comes into play. The choice is also based on politics, right? If I'm a senior manager in a company, and then I have a choice of either building it and or buying it from outside. If I build it, then I'll look good, right? With my superiors. So that means I can get a promotion. If I buy it, then I may not look good, depending on the company, right? But a rule of thumb in the industry is, if you can buy something, buy it. Don't try to reinvent the wheel. That's what we say. Buy versus make. Buy is always the way to go for enterprises. Okay. Okay. We talked about UML and object oriented, so I'm going to uh, skip through these slides fast. As long as you understand use cases, user models, all this is understood for you. We talked about something similar there. Again, this is something that you have seen. This is the nothing but the use cases, right? Remember, you did an assignment last week, and I assume this is what you did, right? You have the users and the use cases. Okay. And for each use case, you create a template which shows who are the actors, and then what is the input and what is the output. Okay. So once you understand that, you get into the design mode. This is where you see the major components, and then you look at the interfaces between those various components. So as you can see here, for the weather station, they came up with some components. I'm not going through those components because you get it by now. Okay. So they abstracted that into, hey, you have transmission of the data, you have receiver of the data. And then the weather, it's basically related to weather here. Okay. Now, how do you identify the classes? Right? Now, we have gone through this multiple times in the past lectures. It's very easy, right? Anything that is meaningful to your application becomes a class, right? And a class would have two things. One is the functions that it executes and the data on which these functions operate. Now, I give you a rule of thumb. When I give you a problem statement, what are the potential objects slash classes? The nouns are the potential objects slash classes, and the verb phrases are the actions or the functionality of the system. Okay. Uh, so anything tangible, right? The other way of looking at it, anything tangible could be a potential object or a class. When we talk about the information system for JNTU Kakinada, we talked about how this information system is accessed by students, faculty members, admin staff, head of department, registrar, those are the users. And then the functionality is described in the problem statement. So those become the use cases. Okay, we covered that. Okay, I'll skip the weather class because I've already done an assignment. Okay, now this one is important. So once you have the uses, you remember we talked about parenthesis notation, right? So parenthesis shows those are all the operations in the class. Again, nothing new here. We covered that. Okay. And when you come to the design model here, all you're drawing is showing a relationship between the classes, right? And then we talked about two types of models. One is the static structure, uh, which looks like the entity relationship model. And then the dynamic model, that is where we got into the behavioral patterns, the sequence diagram that we talked about, right? There's some repetition of the information here between the two chapters. So that's the reason why I'm skipping it. Okay. And then we also talked about state machine model, didn't we? To capture the dynamic behavior. We took the example of a vending machine, right? And then we also covered the concepts of, um, bear with me. We covered the concept of aggregation and then hierarchy, inheritance hierarchies, right? So same thing here in UML. There's nothing new there. Okay. And then we said we draw sequence models to show the sequence of object interactions. Like we took an example, like if a faculty member, I think we took the example of a hospital where when a patient wants to book an appointment, how would he access the online system and go through the process, right? Where we said first we have to verify and validate the patient, right? The authentication. And then we open up, we display the options available to the patient. Then they will select one of the options called schedule an appointment with a doctor. Then the system sends a message to the doctor looking up their availability. And if the availability is there, they book the appointment. So there's a sequence of actions. Okay. By the way, you will be drawing a sequence diagram like this in your test. So this shows you, instead of the medical exercise that we did, this example, here it shows you the sequence diagram for weather data. Exactly the same, right? Couple of chapters ago. There is no difference other than the example. Okay. So you should be fairly comfortable. And how do we read the diagram? We said we go from top to bottom, left to right. Okay. We talked about state diagrams, which show how the objects are of that class respond to the external stimulus. Okay. And the example that we took is a vending machine. Okay. So and then I gave you a similar example, which looks something like this with respect to a vending machine. Okay. Now, how do you specify the interfaces? Right. The way we specify the interfaces, as one young lady answered here in the encapsulation question that I asked, is you typically in the class you show the functions, and then since you learned Java, you know that, right? We say these functions are public and these functions are private. Public means somebody can invoke that function, and private means it's only inside the object. Okay. So as you can see here, these are all the publicly available functions for weather station. And we covered the patterns. Remember, we talked about different types of pattern. And the reason why we use the patterns is we want to reuse the code, reuse the frameworks. Again, there's a lot of repetition here, but it's okay for you to get the same thing over and over again too. Okay, I'll skip some of these things. Yeah, I'll skip this. Yeah, I'll skip some of these. Okay, we'll jump into implementation now. Okay, so when we talk about implementation issues here, notice one thing here. Right off the bat, he's saying that this is not on programming, but what are the issues before you do the actual coding? What are the issues, right? The issues basically when we talk about implementation, one is reuse. We want to reuse code. Second thing is, what about configuration, right? When you have so many different teams working on different parts of the system, what is the process that we use for people to check in and check out their code, right? Let's say I'm working on a piece of code and my team member is also working on the same piece of code. If we do not have proper check-in, check-out facilities, what would happen in this case? Whatever I have done might get overwritten by the other guy, or vice versa. So we have to figure out like CVS repositories, right? They're standard repositories available for development team to do systematic check-in and check-out, and version control, as we call it, right? So all those issues need to be handled by the development team. And then when we write software, we always want to know what is the host target, meaning like, hey, are you doing it in a Unix environment? Are you doing it in a Windows environment, right? So you need to address those issues as well as part of the, like for example, when I was developing an app, we had to decide whether we are going to do it for iOS platform or whether we are going to do it for Android platform or whether we are going to do it for Windows platform, right? That is the host target, right? Okay. Reuse again. We talked about reuse quite a lot. The whole idea of reuse is if you reuse in theory, it is supposed to save you money because you're not developing, you're not spending money again on implementing the same code. And since you're reusing, it also saves you time in terms of QA and testing. And all those things basically mean you will save some time in terms of rolling out your product. Okay. So the name of the game here is, in today's world, it's all about reuse. Okay. Now you can have reuse at different levels, right? When you talk about abstraction levels, remember when you talked about abstraction level, like the 3-tier architecture, where you have the UI, the business layer, and then the data layer. That is abstraction. Okay, you're not reusing code, but you're reusing the framework concepts. Can you reuse objects? Absolutely, right? When you are developing inheritance trees and so on, you can reuse some of the objects from the library. Almost all of you, when you use Eclipse environment, you use a lot of uh, lot of functions from the libraries, right? I'm assuming you use functions such as math libraries, string processing. All of your programs should have done some string processing, right? Like I'll give you like string length. How many of you used a function called string length in your program? Anyone putting in their hand up, or have you used a string length function in your programs or substring or finding a string of characters in a bigger string? Um, Let me ask you this one. Okay, I'll ask you a simpler question, okay? Silly question. Okay, let me see the pictures here. I don't see video from anyone, so I want to see video here. Uh, all the students have written a program, correct? Hold on a second. Did I lose some people here? Did I lose Kakinada? No. So let's see. I don't see video of NTU Vijayanagaram. Put it in chat. Okay. Or Aditya. All of you have written programs, right? Um, do you, in your programs, have you include like an include statement? Did you put an include statement like this? Agree? When the moment you put that one, what does it mean? I know the girl sitting right behind the faculty member is laughing, smiling. What does it mean really when you say include stdio.h? Ignore the comma there. It is supposed to be the symbol like that, right? your program is essentially reusing the functions of all the input output functions, right? Somebody has written that code. You don't have to do a C in and C out to the terminal. You don't have to write how that C in and C out work. You know C in and C out, right? In Java. So somebody has written the program for you and you're reusing that code. So you don't have to reinvent the wheel. That's what the reuse is. So you can do it at different levels: function level, object level, component level, system level, meaning you can reuse the entire application. If somebody has, for example, let's say, done a generic assigning faculty members to courses, okay? If there is another, let's say you have developed that for JNTU Kakinada. Now, if JNTU Hyderabad wants to develop a similar information system, do you think it makes sense for them to reuse your code to assign faculty members to courses? Do you think it'll be different for them compared to how JNTU Kakinada does it? Probably not. They would probably use the same logic. So they can reuse the entire faculty to course scheduling system assignment, right? So that is at the complete application layer level. Now, it is easier said than done. Let there be no doubt in your mind, software reuse is still not completely accomplished optimally. Okay. Um, what are the reuse costs? So how much time it takes to look for software to reuse and assessing whether or not it meets your needs. Very important point, right? Because in my own case, when I was developing Lensu platform, I gave my development staff from May of 2009 till December 2009, May or June, about 6 months. So I had a team of 3 dedicated programmers surveying the field, looking at what can be reused for 6 months. And each programmer in those days was costing me close to $6,000 a month. So almost like $20,000 a month I spent on development staff of 3 for time spent on seeing, hey, what can we reuse out on the internet? See, there's a cost associated with it. There's nothing free, right? Okay. And where applicable, cost of buying the reusable software is much faster. Okay. Now, the other thing is the third bullet point, the cost of adapting and configuring the reusable software. Like for example, we actually went deep into Moodle. Everyone knows Moodle, right? Moodle is an open source course management system. But when we studied the code inside out and we had some specific requirements in mind to configure that, to change it was going to be a much more complex activity than building it from scratch. Okay, so the team has to make those decisions. Okay, okay. Now, all teams, they put together a configuration management framework, as I mentioned in the beginning, right? So we come up with the development environment. We say, hey, here is the development environment. Here is the technology stack that we would use. What is a technology stack? Can somebody tell me what do we mean by technology stack? Have you come across the term technology stack? I see a whole bunch of girls in that room. Raise your hand if you have heard the term technology stack. I'm looking at JNTU Vijayanagaram, I think, in the video. Have you come across the phrase technology stack in any of your classes? Maybe not, or maybe yes. Okay. So what it means is, right, it's basically nothing but architecture, right? your application domain architecture, right? I would say, okay, we are going to be implementing it in Java. We are going to use SQL Server at the database, right? Um, or MySQL. And then at the web layer level, we'll use Apache or Tomcat. Heard about Tomcat server? It's a web application server, okay? Open source software, right? And then we said at that time, the Google uh, came up with the Spring framework. We said we'll use Spring framework. So that's all the technology stack. So those are the type of decisions that you would make in configuration management. And when we come to the end of it, if I get time, I'll get more deeper into that. Okay. Version control. Okay. How do we check in and check out code? How do we track bugs? Right? Are we going to use some bug tracking software like Remedy? Or would it be a simple thing as an Excel spreadsheet, right? Now, what are the various entries? If you're using an Excel spreadsheet, how do you track it? Do you say bug number one? Do you give numbering? And who found the bug? Which module where the bug was found? So what are the various fields of the Excel spreadsheet? So there are a lot of what I call it as, these are all the bookkeeping um, operational tasks that you need to worry about before you go do the actual coding. Okay. So you can see here the various parts of it. One other important thing here is release management, right? How do you know what to release, right? If you have 100 functions to do, would you release it incrementally or would you release it as one big bang product, right? Like I'll give you an example. When we did our app, Lensu Create, we released our first version of Lensu Create in May of 2013. Okay, it had very basic functionality. Just a few features, we released it. If I look back now, what I have now is 10 times more than what we released then. Those are all the type of decisions that the team has to make, or the architecture guy or the tech lead would make in consultation with the business stakeholder. Okay, there's a term that we use called MVP. Let me write it here for you. Okay, what is MVP? You must have heard that term somewhere too. It's called minimum viable product. So what the team decides when you're doing these things, before you write the code, you say, what is the minimum functionality which can be released? So that way the product that you're releasing is meaningful to the user. Like I'll give you an example. In the context of assigning faculty members to courses, right? You say, I'm going to release just enough functionality where you can input the courses and nothing else. There are no faculty members. Is that a minimum viable product? Absolutely not. It's a useless product, right? You can say, hey, I will release a product where through the user interface, I can assign a faculty member to a course. I say, Thirumal Garu will teach this course on software engineering. So that means your product would have a list of courses, a list of faculty members, and then you basically say that you will assign a faculty member to a course. That is a minimum viable product. Now, in the course of designing the system, you might have a lot of other features. Hey, once I assign a faculty member, can I remove it? Meaning, can I remove Thirumal Rao Garu from software engineering and assign Pratap Chidlakanti to that? It may not be there in release 1, it could come in release 2. So that is why one of the things that you decide at this stage is what is known as a minimum viable product. What is the minimum least common denominator, as you call it, right, in mathematical terms. Okay. What is the host target? Unix, Android, different platforms, right? Okay. What are the libraries that you would use, right? What is the IDE? Like, for example, most of my product development team, we use Eclipse. That's the integrated development compiler environment, right? It comes with its own compilers, testing tools, and all that. Okay. Uh, Let me ask a question. For the students there, faculty members, you can answer. What is the IDE that the students use in India? JNTUV or Chakravarti Garu can answer that if you are there. Do you use any integrated development environment? Talking, but I can't hear. But that's okay. You look up IDE students, and what I recommend for most of your projects is Eclipse. And let me type the term. I'm assuming you heard the term Eclipse, right? Use a lot of other things too. Microsoft provides its own IDE, but I use Eclipse quite a bit for all my classes. Okay, and then similarly, you have testing tools like Junet. I don't know what Junet is. I've never used it. Okay, I very rarely use any of the testing tools, but there are a lot of testing suites available. Okay, let me go back here. Okay. What is an IDE? It's a set of tools that support different aspects of software development. Actually, it's a good exercise. I'll post a discussion question in the community where I want you to go and research IDEs and come up with different IDEs that are there. Okay. I will do that as part of an exercise for us. Okay. Okay. Questions, comments? The other aspects of this chapter are about open source development. You know, the world has moved to open source development now, right? Lot of the software that's available is open source development, and the precursor for open source software development, you should look up GNU, started by people at MIT long time ago, where they said the entire software should be free. People should not be paying for software. So there are a lot of things, like if you take Moodle, the most popular course management software used by majority of high schools in this country is an open source software, free. Okay, you just download it and do it. Like same thing, Drupal, DRUPAL, another course management software. Okay. Similarly, so I'm assuming you know a lot of the open source software. Okay. Now there's a good thing and bad thing, right? Good thing is somebody has done that. Thousands and thousands and thousands of programmers, they come and develop these systems. If you look at Wikipedia or different versions of Unix, okay, or MySQL. MySQL is an open source software, or it used to be, right? And then who bought it out? Oracle bought it out later, right? So that was a classic example of a database software which was open source and it was free for everyone. Okay. There are a lot of advantages, right? It saves you time, but the disadvantages is you have to use it as is, right? I'll give an example of an open source software that we used for our platform. Okay. The discussion forum that you see there, the community, we actually use an open source software and customized it. There's another open source software that we use which supports video conferencing. But the problem is this, that video conferencing supports video conferencing between up to 25 students only. So it doesn't help us, right? It's only there for demo purposes. If I want a full-fledged video conferencing system which is free, I still don't have a solution for that. Okay. So most of the time when you are building products now, we always go look for open source software, especially in the areas of e-commerce, in the areas of collaboration, because there's so much of free software available. So somebody on your technical team would go play with it and then do kind of a feasibility analysis and study and produce a document which says, hey, I can use 60% of it, or I can use 80% of it, right? So that analysis they do, and then they get the approval from the management as to whether they should use it or not. Okay. Problem is this: when you have open source software, it's like as is, right? There are no guarantees. If it works, great. If it has any problems, they don't make any kind of claims that they protect you. Now, where do you think one big problem would be to use open source software in today's world? If security is a big concern for you, you have to be very careful about using open source software. Okay. Now, there are some licensing issues when you are using open source software. Is whenever you are adding to it and making new changes and so on, most of these guys say you have to put it back in the community. Whatever changes that you are doing, you release your changes to the open community. Okay. Okay. Different licensing models, nothing of interest to me. You can take a look at it. Okay. But in summary, what this chapter basically tells you is, hey, before you write the actual code, you have to figure out a few things in implementation. One is, how do programmers, they all work together? What is the architecture that you would use? What is the technology stack? What is the database? What is the programming language? And how do you manage all your code? How do you manage changes? What kind of version control we will use, right? So all of those things you have to decide and set up that infrastructure, the development infrastructure. Typically, we set it up around an IDE, and then we then give the green light to going and doing the actual coding. Okay, so that is the essence of this chapter. Questions, comments? I'm going to put a community question there in our forum where you are going to go research on IDEs. Chakravarti garu cheppandi, I'm done with the class today. Echo is coming. I'll unmute Chakravarti garu.
Yes, sir. So we can close it.
We can close. Okay. Now, are we on track for the October 12th exam?
Yes, sir. Yes, sir. The other thing is we need to keep these chapters in our community, I think so.
They are there. Up to this today's chapter, they are in the community.
Okay, right. Thank you, sir.
Okay. And then I'll post the next set of chapters after the midterm.
Okay, sir. Right. Thank you.
Okay. Thanks, and have a wonderful rest of the day, folks. Bye.
Thank you, sir. Good night, sir. Good night.